Okay, let's look at this problem number 6, which is from Chapter 6. I changed it a little bit, but it's this function that has x squared plus 3 cosine of x, and we're only interested in the interval from 0 to 2 pi. And what we're going to look at is find the intervals where it's concave up or concave down, and we're looking for the points of inflection. So recall that we're going to look at the second derivative, and when it's less than 0, that indicates that it's negative, and it would be concave down, something like this. And when the second derivative is greater than 0, it's going to be positive, and it would be concave up. And so to find these points, these concavity points, we're just going to first see if we can find where the concavity merges together, where it switches from being concave up to concave down, or vice versa. So that's simply setting the second derivative equal to 0. So let's go ahead and take the derivatives. We have the first derivative, 2x minus 3 sine of x, and the second derivative would equal 2 minus 3 cosine of x. And we're going to go ahead and set that equal to 0. So we have 2 minus 3 cosine of x. When is it equal to 0? So we subtract 2 from both sides and divide this by -3, and we get that our cosine of x is equal to a positive 2/3. So how do we solve for x in this case? That's right, we're going to use arc cosine. So we're going to have to use our calculator to find this, because that's not one of the values that we're responsible for knowing. So let's just punch it up on the calculator and see what we get. So we have the inverse sine of 2/3 is equal to 0.8410 0.8412, we'll call it. And that's in radians. And this is a positive value, right? So if we think about this for a second, we have to take a look at our unit circle. Well, let's drive home the point real quick. If the cosine of 0.8412 radians equals that 0.666, which is approximately 2/3. Of course, I rounded a little bit, but anyway, hopefully that helps working back and forth between arc, cosine, and cosine. So let's see if we can kind of picture this. Let's draw a unit circle up here, and let's do it over here, I suppose. And let's draw some axes, and something like this. And what do we know? We know that, well, if we look at our rainbow, just to keep it fresh, we have sine, cosine, tangent, cotangent, secant, and cosecant. And tangent and cotangent are reciprocals of each other. Secant is the reciprocal of cosine, and cosecant is reciprocal of sine. And sine, we usually say, is built on y when it's on the unit circle, and cosine is really just your x value, and tangent is y divided by x. So this is a positive value, so when is it equal to positive? On your unit circle, Hopefully it's becoming pretty obvious to you at this point, but never hurt to review a little bit. This is just when the x is positive, so if we have a very small measurement of radians here, whoops, don't know how that just happened. But if we have a very small measure, and that's 0.8412, where else is it going to be positive? Well, it turns out that the width of this slice here has a counterpart over on the other side, and we'll do that one in blue, I suppose. It's got a counterpart over here that shares the same width. This one I'll shade in green. So, my question is, how do we calculate what this counterpart is that I drew in blue right here? Well, let's think about taking a trip around the unit circle. If I go all the way around this unit circle, that's worth 2 pi, right? But the angle that I need, the measurement is all the way around, but then I have to back off or subtract the width of this highlighted in green. Well, that's just subtract 0.8412. So that should be our second value when the derivative is equal to 0. So let's check this with the calculator. So we know that the cosine of 0.8412 is equal to 0.666, right? So it stands to reason that if the cosine of 2 pi should equal the same thing when I subtract that 0.8412. Come on, calculator, work with me. Oops, I punched in cosine inverse, I'm so sorry. Change that to cosine. And it's equal to, very similar to what we had, 0.666568, so that's 2/3. So we have our 2 points. We just need to actually type in 2 pi, not 5 pi, 2 pi, subtract that 0.8412, and that's equal to 5.44. Let's get that back up there. 5.442, let's say. Now we did 4 places before. Let's do 4 again. 4420. Okay. So this is when our possible points of inflection are. So of course we would draw our number line down here, and we'll analyze our second derivative. And so what do we have? We have the second derivative here. What in the world? Let's try that again. The second derivative, we have a value at 0.8412, and then we have another value over here at 5.442, and we know it's 0 there. 0 there, the second derivative is. And we just need to pick a value that is a little bit less than that. So how about we just use, since we're going to have to use the calculator, since we're allowed to use the calculator to do this part, let's go ahead and use the calculator to analyze the derivative. So let's write down the derivative again, because it kind of got lost in the shuffle. Here it is, right here. So we're going to plug in 2 minus 3 cosine of how about we just do 0.5, and see what we get. So we have 2 minus 3 cosine of 0.5. and we get that it's a negative, and that's all we're really concerned with. Negative. And then let's try a value in between, say 1. That'll be fine. So I'm just going to hit second enter and recall the last command we did, and that's a positive 0.379. So it's positive, positive. And finally, let's go try one a little bit to the right, but it has to be less than 2 times 3.14, 6.28. So let's try just, we can just do 5.75. That's a good number. And we see that it goes back to negative again. So what do we say about this? How do we write this final answer up? It's asking us about the intervals of concavity, so we can say that it's concave up on the open interval of 0.8412 to 5.442, because the second derivative is positive right here. And we could even make that statement because the second derivative is greater than 0 here, and it's concave down on the interval of, that's closed interval, from 0 to 0.8412, and from 5.442 until our endpoint, which is 2 pi, because that was our given interval here in the stated problem. And once again, that's because the second derivative is less than 0 or negative, and we have 2 points of inflection. 2 points of inflection is when x equals 0.8412 radians and x equals 5.442 radians. And it's a point of inflection because the second derivative changes signs at those given locations, at those points. Sounds better? Okay, so hopefully this wasn't too scary of a problem. The main concept here that might have been a little bit tough to handle at first was, well, we found the positive value when we found our point 8412, and we said that that would be over here where it's a little bit positive. And knowing that in this quadrant all trigonometric functions are positive, and in the second quadrant only sine is positive, and over in the third quadrant tangent is positive, and over here cosine. And just to mention, if cosine's positive, what does that tell us? It tells us that also secant is, but that wasn't important in this problem. But hopefully this was a nice little review of your trigonometry, and hope you can finish the rest.